Welcome to Common Logarithms. This is section 11.5. We're going to be talking about base 10 logarithms. You see some properties of base 10 logarithms on the screen. Log to the x equals y. What does that mean? 10 to the y equals x. Notice we rewrote it with a base 10 number. Log to the 1 equals 0. That's 10 to the 0 equals 1, so on and so on. So all of our logarithms for common logs will be base 10. So we don't typically write that when we write the log, and that just means 10 to some power. Remember, the logarithm would be the exponent. Here's a typical problem we use in section 5 to evaluate these two logs. So let's look at them. We need to rewrite it. Since we have a multiplication, we have 5 times 2 to the third. We can rewrite that as log of 5 plus log of 2 to the third. But we never leave the exponent. We have to bring the exponent down in front of the log, so we rewrite that further as log 5 plus 3 log of 2. The log of 5 and log of 2 have numeric values you find on your calculator. You would punch those in using the log button. Log of 5 is 0.6990. And then 3 times log of 2. Log of 2 is 0.3010. So simplifying that, your answer would be 1.6021. Remember, these are approximations, so they're not going to be 100% accurate. So if you are 1 digit off, 4 digits past the decimal point, then that's not going to cause a major problem. Likewise, for the second problem, when you have a quotient, that means subtraction. So we would break this down as log of 19 squared minus log of 6. Remember, we have to move the exponent to the front, so 2 log of 19 minus, that is, log of 6. I didn't write it the first time. So we evaluate that using the calculator, so that would be 2 times log of 19, which is 1.2788, minus log of 6, 0.7782, and I'm running out of room here. The answer would be 1.7794. So that is how you evaluate common logarithms. Another problem we will run into in section 5 is change of base formula. Change of base formula simply states when you have a base that's not base 10, how do you use common logarithms to solve the answer? For example, we have log base 9 of 1043. We can use common logarithms to solve this using the change of base formula you see at the top. So we would rewrite this using the change of base, so that would be equal to the log of 1043 over the log of 9. And notice on the logs I did not write, because the 10 is, for common logarithms, is assumed, so you don't have to write it. So the log of 1043 is 3.0183. And the log of 9 is 0.9542, 9542, excuse me. And when you divide those, the answer is 3.1632. And there is your answer. The last type of problem is to solve using logarithms. And when we're solving, we're trying to find the x, or we're trying to find the exponent. So we've used logarithms on both sides, set them equal to each other. So log of 6 to the 3x equals log of 81. Remember, anytime you write it as a log with an exponent, you move the exponent to the front. So 3x log of 6 is equal to the log of 81. And we're going to divide both sides by log of 6 in order to get rid of that. So we would divide both sides by log of 6. And of course those cancel, so that means 3x equals the log of 81 over the log of 6, which is, on your calculator, you would punch that in. and then taking each side, taking that answer and dividing it by 3, x would then equal 0.8175. Remember, you have to divide by the x, or the 3 on the x, in order to get x by itself. So whatever this answer is, log 81 over log of 6, you would then further divide it by 3 in order to get x. So that concludes section 5. Make sure you know your properties for common logs base 10.